Hey, it's Maths Athlete. That's a tongue twister, I just realized. Maths Athlete, yes. This is Core Mathematics A-Level, Lesson 5, Rationalizing the Denominator. We are one step closer to finishing this topic. Okay, so sometimes we are given fractions where the denominator is a surd. However, with a bit of our surd knowledge, we can rearrange that. So, say we're given, black is so plain, 3 over root 5. Let's draw that nicely. 3 over root 5. Now, the denominator is irrational, and we want to rationalize it, so make it rational. And knowing the rule in green, root a times root a equals a, we can do this. So if you can see where we're going now, we are going to times the denominator by itself. So let's change the color. So now let's times it by root 5 over root 5. Now, before we go any step further, we're not changing its value because root 5 over root 5 is 1. And when you times anything by 1, it does not change its value. So say we have a half, and we times it by 2 over 2, it's 2 over 4. That's still a half. 2 is half of 4, right? So, yeah, forget about that. Let's move this here. The answer will be 3 root 5 over 5. And that is the simplest way of rationalizing. So this rule is therefore as follows. So it's therefore as follows. If the denominator of the form root n is of the form root n, then you multiply the top and bottom by root n. So say you have 1 over root n. I really should be doing this in a different color. You times it by root n over root n, which is 1. And n being any integer, this will be root n over n, because root n times root n is n, and that is rationalizing the denominator. So let's do another example. Let's write rationalize. I hate writing on this pen thing. I'm more of a maths guy, so it's all numbers for me. 5 over root 3 equals 5 over root 3. And what do we times it by? Different color. Root 3 over root 3. And that will equal 5 root 3 over 3. And that is rationalizing the denominator. So we went from irrational, which is root 3, to rational 3. So now, because we know the basics, of course, we have to advance, sadly, to the harder examples. So say, what about if we're given 4 over 2 plus root 3? What do we do? Well, using our surd knowledge, yes, we know that since 2 plus root 3 times 2 minus root 3 equals 2 squared, which is this, let's do a different color, this times this, that's your 2 squared. And we know that it also equals minus 3. Now, why do we say 2 squared minus root 3, which is of course equals 1, because 4 minus 3 is 1? is because when we times 2 by minus root 3, which is minus 2 root 3, and 2 times root 3, you get, say we expanded this like we usually expand. What's special about when you do the opposite of the first sign is when we expand this, we get 2 squared, and let's do this in a different color, plus 2 root 3 minus 2 root 3, and then we're back to minus 3. You notice that this and this cancel out, so we're back to this and this, which equals 1. And when we conjugate this, we'll end up with, let's use a color. So if we end up timesing it by this, we'll know that it equals 4 times 2 minus root 3 over 1. Sorry, why did I write times there? I think we need more space. Let's get more space. Let me rub this out. This is a long procedure. Let's write this, hopefully I don't forget it. It is pen 4 over 2 plus root 3 times this. We're going to times it by this because we know that equals to 1, and 1 is a rational number. So now we have 2 minus root 3 over 2 minus root 3, which is again 1. 2 over minus root 3 over 2 over minus root 3 is the same as 1. This equals 4 lots of 2 minus root 3, and because we know that this times this times this equals 1, we can just put it over 1. And when we put a number as a fraction over 1, we always know that it's just the numerator, basically, because when 1 is the denominator, it does not count. So this page looks kind of messy. Let's get to a new page. So now we've noticed something. We've noticed that there's this special technique, and luckily mathematicians have discovered this years ago, is something called the conjugate, which is what you times the denominator by when you want to rationalize it. So say you're giving a plus root b, and it's 1 over, and you're trying to rationalize it. The conjugate will always be the opposite. You always change the opposite of this. So the conjugate, I keep on changing colors. The conjugate will be a minus root b over a minus root b. What you times by the top, you times the exact same by the bottom. So you're not changing the value. And this is the conjugate. So if it's the other way around, say we have a minus b, the conjugate will be a plus, a plus root b, yes. And this is known as the conjugate. Let's put this into practice. So we're asked to simplify this fraction here. We're supposed to rationalize it, and looking at the denominator, we know exactly what the conjugate is. So let's do this. Let's say equals 4 over 4 minus root 12 times the conjugate. Conjugate from now on, we'll write it in red. So we'll do 4 plus root 12 over 4 plus, I keep on writing my root sign's weird, and you've probably noticed that throughout the videos. So if we simplify this, let's do the bottom first. So we do 4 times 4, which is 16. We'll do 4 times 4 root 12, and then 4 times minus 4 root 12, and they cancel out. And so we just have minus root 12 times root 12, which is minus 12. So that's the bottom done. Now we have 4 lots of 4 plus root 12. So that's 4 times 4, which is also actually if we can actually simplify this, we can actually do, I just worked it out, we can do 4 plus 4 root 12, and because we are amazing at cancelling out, 4 plus 4 root 12, and 16 minus 12 is 4, so we can simplify this, and we are amazing, and the final answer is 4 plus root 12. I'll write that again, because that's the same as 4 plus root 12 over 1, which is 4 plus root 12. I really need to fix up my root signs. Let's use another example. Sorry, I meant to do another example, not use another example. That didn't make sense. The conjugate. Let's write the conjugate here. The conjugate equals root 6 minus root 3. Remember, all you have to do is just change the sign here to the opposite of the denominator, and it will rationalize it. So let's write this out. 1 over root 6 plus root 3. You know, I'm thinking of changing my name to Example Man, because what I do is examples, and examples benefit. So now we have root 6 minus root 3 over root 6 minus root 3 equals, let's do equals here, because we have to line them up. Always make sure you line up your equal signs, otherwise the examiner will get lost when he's marking your work. So that's 1 times root 6 minus root 3, so that's, should keep that blue, because that's only for conjugating. 6 minus root 3 over, okay, so now we have root 6 times root 6, which is 6, and then we have root 3 times root 6, which is 18, root 18, and then we have root 6 times minus root 3, which is negative root 18, and they both cancel out, and so we just left with root 3 times minus root 3, which is minus 3, and the final answer is root 6 minus root 3 over 3, and that is rationalizing the denominator, and this is the rational number. 3 is rational, yes. Next page. Okay, so final example. I thought we'd give a hard one. Let's write the conjugate. My handwriting getting smaller and smaller, so that's root 3. Remember, the conjugate always is dependent on the denominator that you're rationalizing. And see, this is what I love about maths. It's so great how things cancel out, and yes, don't know what I'm talking about, but let's rationalize. Root 2 times root 6 over root 2 times 6 root 3, and then root 3. Whoa, that was dangerous. Plus 2 root 5 times the conjugate. See how multiplying surds becomes handy? If you haven't already, check the video before this, and you will know what I'm talking about. So now let's equal that. So root 2 times root 3 is root 6. Root 2 times minus root 2 5, which is root minus 2 root 10, and then you have 6 root 3 times root 3. So root 3 times root 3 is 3, then 6 times 3 is 18, and then you have 6 times minus 2, which is minus 12. So why did I put a plus there? Root 15, then all over root 3 times root 3 is 3, and then they cancel out the 2 root. Basically, when you times 2 root 5 times root 3 is 2 root 15, and then root 3 times minus 2 root 5 is minus 2 root 15, so they cancel out. So we're left with 2 times minus 2, which is minus 4, and you're left with 5 times 5, so it's 5 times root 5, which is 5, and then 4 times, I just confused myself. Okay, let's do this with colors, because now none of us will be confused. Orange. So that's minus 4. Let's write that down. Minus 4 times 5. So that's 3 minus 20, which is minus 17. So let's write this. This is dangerous. So we have root 6, and then we have, so now it's root 6 minus, okay, wait, let's divide this. Can't do my lines. Okay, that was safe. Minus 2 root 10 plus 18 minus 12 root 15 all over minus 17. If you do not want the denominator minus, you can change all of the signs, so you can have it as, I'm going to do an illegal move and move everything to the left. And if you want the denominator to be positive, you can have everything changes in sign. So this becomes negative, and then this becomes positive. So you divide it all by minus 1 basically, and then this becomes negative, and then this becomes positive, and this is all over positive 17. This is the final example. This is rationing the denominator. It sounds crazy, but it really is easy, as long as you know the rule of conjugating, and everything else will fall in its place. Thank you for watching. Subscribe if this has helped you. Comment on the comment section below for feedback. Message me if you have any questions. If you want to ask me any questions I can solve for you. More videos will be coming soon, and thank you for watching, and goodbye.